This video is about how to use the equations of motion to solve projectile motion problems. So let's review what projectile motion means. There are two parts to projectile motion: vertical motion, which is free fall, and horizontal motion, which is constant. Free fall vertical motion means the only acceleration being experienced is the acceleration due to gravity. There is no air resistance, and since there's no air resistance, the horizontal motion will remain constant as the object flies through the air. The only acceleration is vertical and has the value of negative 9.8 meters per second squared when we're near the surface of the Earth. These are the concepts that we're going to use when we solve problems in projectile motion. The key to projectile motion is organizing your work. Horizontal and vertical motion are independent of each other. That means that moving horizontally does not affect how things fall. And having a falling motion doesn't change the way things move sideways, which is why the horizontal motion is constant. So in order to organize our work, we want to separate the one problem about moving sideways and up and down into two simpler problems, one where we only move sideways and one where we only move up and down. The sideways problem has constant motion. We know how to do that. The vertical problem is free fall. We know how to do that. The equations of motion that we're going to use in either case are that the final velocity is the original velocity plus AT, and displacement is original velocity times time plus half AT squared. These are the same equations of motion that we've been using for any kind of motion that has constant acceleration. And the acceleration of gravity is a fine example of constant acceleration. So we want to divide and conquer. That's our motto here. So how do we divide and conquer? Well, we know for horizontal motion it's constant. That means there is no horizontal acceleration. Our velocity is our original velocity. It doesn't change. And so when we look at the equation of motion for displacement, the 1/2 AT squared part goes away because A is 0. And we're left with a very simple displacement equals original V times T. On the vertical side, A equals negative 9.8 meters per second squared. So when we substitute negative 9.8 for A into our two motion equations, we get V equals original V minus 9.8 T, and displacement equals original V times T minus half 9.8 times T squared. All right. The right-hand side should look very familiar. This is the free fall motion that we did in the previous unit. The left-hand side goes back to Unit 2 or Unit 3 where we had no acceleration and constant motion. So how do we take this and use it to solve a problem? All right, well, here's an example of a projectile motion problem. A cheetah jumps horizontally from a 3-meter tall boulder and lands 6 meters from his launch point. With what horizontal speed did he jump? So we're going to have to take the information that's provided, decode some of the words here to get some additional information, plug it into our horizontal and vertical grid, and see where we get. All right, so here's the horizontal and vertical grid. Let's work on the horizontal motion first. Cheetah jumps horizontally from a 3-meter tall boulder. 3 meters tall, that's the vertical displacement, so I don't need that. And he lands 6 meters from his launch point. 6 meters is my horizontal displacement. So that's going to go on the horizontal side of my chart. I have no horizontal acceleration. The horizontal speed is what I want to solve for. My horizontal displacement is 6 meters. My horizontal equation of motion is displacement equals original velocity times t. if I substitute what I know, this is what I get. The problem here is there are two things I don't know. I don't know the original velocity, and I don't know how much time it took. So right now, I cannot solve this problem. Let's take a look at the vertical side and see if this gets us anywhere. Vertical acceleration for these problems is always negative 9.8 meters per second squared. The cheetah jumps horizontally. That means he doesn't jump up and he doesn't jump down. So my original horizontal velocity is 0. He jumps from 3 meters down to the ground. So my vertical displacement is 3 meters down. The negative sign means down. I make my substitutions into my motion equations. V equals original velocity, which is 0, minus 9.8 times t. And my displacement is original velocity times t. That's also 0, minus half of 9.8 times t squared. So I substitute everything I know into my vertical motion equation. My vertical displacement is negative 3. Half of 9.8 is 4.9. T is the only thing I don't know. This I can solve. These problems are always going to set up this way. There will be one side that you can solve, and then you will take that information and go to the other side. The only thing that these two sides have in common is the time it takes to do the motion. So usually we're going to solve for t and then take t over to the other part to solve for what we want to know. So to finish this problem up, we're going to use our vertical side to solve for t. We get t equals 0.78 seconds. And now I want to take this time and I want to make a substitution for t in my horizontal motion equation. There it is. 6 equals original v times 0.78. And then I solve for my original v and I get 7.7 meters per second. So let's recap this process. Whenever we have a problem that goes up and down and sideways, we want to split the problem into two parts. A horizontal or sideways part, which has constant motion, and a vertical or up and down part that has constant negative 9.8 meters per second squared acceleration. Then we take our equations of motion, substitute what we know from the problem, and we'll always be able to solve one side of this t-chart and then make a substitution into the other side to get the thing that we want to know. That's how you organize your work to solve projectile motion problems.